Let's talk about what it means for a function to be continuous. This is just a very quick calculus 3a review. Let's take a function f of x. If you notice, while I drew that function, I didn't have to lift my pen. A wise math colleague friend of mine once told me that if you don't have to lift your pencil when you are drawing a function, then that function exists in that region. So here, if we wanted to find the limit of this function at x equals a, we would say that the limit of our function as x approaches a is equal to the value of f evaluated at x equals a. Now, how we arrived at that is by approaching x equals a from both sides. For example, this limit exists if when we approach the point x equals a from the left, so here we're approaching x equals a from the left, notice our function approaches the value of the function evaluated at a. And if we approach x equals a from the right, notice that we approach the same value of our function evaluated at x equals a. Because when we approached x from the left, and we got it being evaluated at FA, and when we approached it from the right, we got the exact same value, we could say that this function is continuous. It has the same limit from the left side as we approach the point as we do from the right side as we approach the point, and that value happens to be equal to the value of our function at that point. Well, let's look at a different example. Let's look at an example in which we have a discontinuity in our expression. Let's say our function looks like this. Notice I had to lift my pencil. So there is a discontinuity at x equals a. Well, when we look at this, let's look at the limit of our function as we approach x equals a. And we will just say that this is some value, I don't know, I'll just call this value L. So when we approach x equals a from the left, notice that we are approaching the function L, or the value L. So the limit as x goes to a from the left of f of x, we approach a certain value L. Let's do that from the right-hand side. So if we approach x equals a from the right-hand side, notice that we approach the same value L. So from the right-hand side, we approach the same value L for our function. So this is a situation in which the limit exists. The limit can exist and the function can still be discontinuous. The limit exists, but there's a hole right in the middle. The function does not exist at that point. Since f of x is undefined, at that point x equals a, we have to say that this function is discontinuous at x equals a. Well, even if f of x was defined at that point, f of x might be this value up here. So we could define f of x to be our value f at point A. This is still discontinuous because for a function to be continuous, the limit as your parameter approaches a certain value, the limit of your function has to be equal to the value of your function at that point. In this situation, the value of our function at that point is different than the value of the limit. Since the value of our function at that point is different than the value of the limit, we would say that our function is discontinuous at x equals a.